Hello students, today I will discuss some important terms used in coordination compounds. Okay, please listen to the term homoleptic complex, homoleptic and heteroleptic complex. Then the first term, homoleptic complexes. What is meant by homoleptic complex? The complexes, the coordination compounds in which the central metal atom is bound to only one kind of ligands, okay, are called homoleptic complexes. Please listen the example. CrNH3 6 3 plus. Here the central metal chromium is bound to one kind of ligands, that is ammonia. Okay. The next example, NiCO4. In this case, the central atom nickel is bound to one kind of ligand, that is bound to only CO ligand, carbon monoxide, which is called carbonyl ligand. Okay. Then the next example, FeCN6 4 minus. Here the central metal ion is bound to only Cn minus ligands, then Cr H2O 6 3 plus. Here the central metal chromium is bound to only the ligand water molecule. That means the complexes in which the central metal is bound to one kind of ligand is called ligands are called homoleptic complexes. Yes, the next term is heteroleptic complexes. But what is meant by heteroleptic complex? The complexes in which the central metal is bound to different kinds of ligands are called heteroleptic complexes. Example, please listen. CO NH3 5 Br 2 plus. Here the central metal cobalt is bound to different types of ligands, that is NH3 and Br minus. Then the second example, Cr H2O 5 Cl 2 plus. Here the central metal chromium is bound to different kinds of ligands, that is H2O and Cl minus. Okay, we can consider one more example. CO En twice Cl2 plus. Here the central metal cobalt is bound to ethane 1 to the ligands, ethane 1 to diamine and Cl minus. Okay. The next important term is coordination polyhedron. Coordination polyhedron means what? It is the spatial arrangement of ligands which are directly attached to the central atom. The ligands which are directly attached to the central atom, directed in space in some preferred directions to acquire stable geometry. Yes, please listen. The common coordination polyhedron are, the common coordination entity are: number 1, tetrahedral entity, then square planar entity, then trigonal bipyramidal entity, octahedral entity. Yes, tetrahedral entity. The example for tetrahedral entity is NaCO4. Here the ligand CO for carbon monoxide molecule attaching to the central atom, okay, attains tetrahedral shape. These four CO ligands directed towards the four corners of a tetrahedron. Then the coordination polyhedron is a tetrahedral. Yes, the next square planar, okay, the example is PTNH3 twice Cl2. Here the central atom is platinum, ligands to NH3 molecule and to Cl minus, which attains square planar shape. Square planar shape. Yes. Then square planar shape. NaCO4. Tetrahedral shape. It attains tetrahedral shape. Okay. Next, octahedral shape. Octahedral entity. Octahedral entity. Example Cr NH3 6 3 plus chromium. The 6 NH3 molecules directed towards the 6 corners of an octahedron. Okay, the shape of coordination entity is octahedral. Attains octahedral shape. And one more we can say, yes, that is trigonal bipyramidal. Okay, trigonal bipyramidal. Please listen. Trigonal bipyramidal. The example is FeCO5. Okay. FeCO5. Fe FeCO5. It adopts trigonal bipyramidal geometry. Okay, students. Goodbye. Study well.